Okay, so this video is to help with practice number 7 of our FRQs. So I don't have anything on here for practice 1 or the first FRQ of 3, and that's because that one's kind of been repetitious. There's an Euler's method, a Taylor polynomial, that sort of thing. So just for the Euler's method, just to jog your memory on Euler's real quick. So you would have an x, you would have a y. And then you need to find delta y, which would be your derivative, so whatever your derivative is, and then times delta x. And so you would have some sort of initial value for your x, right, whatever that is. And then to find the next value of x, you would add delta x, and then to find the next value of y, you would add delta y, which would be what you found using this bit of information above, okay? All right, and then your Taylor polynomial. So again, this is just to support just a little bit of your first FRQ, but I'm not going to do much with it. And then just to build your Taylor polynomial, so anytime you want to do a Taylor or Maclaurin, right? So Taylor polynomial, you would take your nth derivative evaluated at your center. So sometimes they say about x equals, about c, or c equals. So just kind of listen to that language or read that language. And then times x minus c to the nth power, all divided by n factorial. And that's how you would find each of the different terms. And then c, of course, would be 0 if you're working with a Maclaurin polynomial. Okay, so that's, a little bit of that one. All right, so then let's go ahead and take a look at some area volume, because that's what part of the next 2 FRQs are going to be. So just given 2 graphs, so just going to do 2 random graphs here. So we'll say this one is f of x, and we will say this one is, let me use a different color for this one, and then g of x. Let me extend that just a little bit here. Okay, and we're just going to call this A right here, so for area. All right, so different things that you can do here. So let's just start with area. So if I want to find the area of region A, so bounded by F and G, right? So how would I do that? So the area is just going to be the integral. And then you would have to find this intersection here, so we'll just call that B. And how you would find that intersection is you would just let f of x equal to g of x. And for that, you can actually use your calculator, right? So you would graph the two. My guess would be it would be on the 2020, because it's no calculator, that they would probably have something more along the lines of a generic, like it would be B, like that's what I could see them potentially doing, is something like that. All right, so then the area then, of course, would be the integral from 0 to B, because that first intersection right here is at the origin, which is 0, and then top minus bottom, right? So the top function across the entire area, right, is defined by the function in blocks, so that would be f of x. And then the bottom of that is, so if we go straight down into here, that bottom is defined always by g of x. So f of x minus g of x, and then dx, right? So that would give you that area there, okay? All right, so let's see here, and let's go ahead and do a volume and a cross-section also, just to kind of remind you of that. So let's take a look at, so let me, So let's say that we want to go about the line. So I'm just going to go up here somewhere. Nice straight line there. And we're going to just call that y is equal to, and I'm going to actually give it a number value, say 5, so y equals 5. So we want to take that area A and we want to revolve it about the line y equals 5. Okay. So if I want to find that volume, so that volume there, so I am working with washer method. And so remember that every single radius that you draw always has to draw from the axis of rotation. Sorry, drew a blank there. Okay, so let me kind of delete this a little bit. So I'm not looking at all that. Okay. So when I take a look at finding, okay, so let me say that again. So every radius that I draw always has to start from the axis of rotation, which in this case is y equals 5, and then it has to go to all my functions. And so when I'm looking here, I have two different functions, right? I have f of x and I have g of x as well. And so that means that they have to go to both of those, right? They have to draw to both of those. So I'm going to start with 2 dots up here, because I know I have to draw to two functions. And so I'm taking this region here, and I'm going to spin it around y equals 5. So when I draw to the closest function, so that would be this guy right here, I'm stopping at my g of x, and then I'm going to go to the further one, the one that goes further away, and that will stop me at g of x. So I have a capital R and a little r. So capital R, of course, is the one that travels the farthest, which is going to be the one traveling to g of x. So this right here, that would be my capital R. So then I want to do top minus bottom. So the top dot is always resting on 5 minus, and then the bottom dot is always resting on g of x. So 5 minus g of x. And then little r, so the shorter distant one, is top dot also resting on 5, and the bottom dot is resting on f of x, so 5 minus f of x. So volume, so this would be Washer method. So that would be pi, and then again we're going from 0 to the intersection of those two functions, which is b. So pi, and then capital R squared, so capital R squared. And then minus little r squared. Whoops. How about little r, which is f of x, and then squared, and then all of that with respect to x. Okay, so that would just give you, area and volume. Okay, so let's go ahead and take a look at another style. So we'll do something a little different. Okay, so I'm still going to be sticking with, doing different functions and such. But so let's take a look at so we'll call this one F. And G. Okay, and so in this case, let's say this first intersection is at 1, and that's at B. Okay, all right, and so let's go ahead and take this right here. All right, so let's find, so we're going to do a cross section. So let's say that we'll do two different cross section ones. So let's say that our first cross section is going to be an equilateral triangle. So we're going to start with that area formula, which is root 3 over 4 and then s squared. So we'll start with cross section, root 3 over 4 s squared. And we're going to go perpendicular to the x-axis. So perpendicular to the x. And we'll do it of the area bounded by f and g. Okay, so for that there, so then our side is just top minus bottom, just a lot like we do radius or height. And so we just go top to bottom. And so remember that is one side of the equilateral triangle. So we're going to call that S. And so we're going to define S right here. So that's the side of the equilateral triangle. And that's just top minus bottom. So that's defined by f of x and then minus g of x, which is your bottom. So then volume is just going to be, we just take that formula, right? So we're going to take this formula right here. And then we're going to take what we have for S and we're going to replace it, right? And that will give us our volume formula for cross sections. So we would have root 3 over 4, which is our scalar. And then we're going to integrate from 1 to b. So from 1 to b. And then S, which is f of x minus g of x, and then squared. And then that would be it, right? So the only thing that was kind of tricky about our cross-section problems is if we were given, where we have to work with the circles because of that diameter radius business. So let's kind of go over that. So we're going to do a cross section of a semicircle. So a semicircle meaning a half a circle. And so that area formula, so area typically is pi r squared, right? So we're just going to do 1/2 pi r squared because we're working with a semicircle. So when we take a look at that same picture above, the difference here is that instead of that being S, that is actually going to be diameter, right? So when I take a look up here, I have to say, okay, this is no longer the side of a triangle. This is now my diameter, right? So that would be the edge of that semicircle, so that would be my diameter. And the problem here, though, is I don't want diameter, right? I don't want f of x minus g of x. I want the radius. So that radius then would be half of that. So I would have to take half of f of x minus g of x. And that's what I would have to then use for my replacement, right? So then this radius right here is what would have to go into that equation. All right. So for my volume then, if my cross-section is a semicircle, would be volume equals 1/2 pi can go out front, because that's just my scalar, from 1 to b, and then radius squared. So what I remember is that 1/2 oftentimes got pulled out, sometimes a little early. So you need to remember that it's quantity squared. So that 1/2 needs to be squared as well. Okay, so that would be cross-sections. Or two different methods for cross sections. Okay, so that should help you out with question 1 and, question 2 and part of question 3. So one more concept in kind of that same realm as far as like area, volume, that sort of thing, is arc length. So just to kind of remind you about that. So let's say that we are given, so something similar. Let's do, I don't know, like we'll do that guy right there. So we'll call him F. And then we'll do this one right here, straight line, and we'll call that G. Okay. So we will say that, let's say this is at 2, and maybe this will be at, I don't know, we'll let's use C over here, and then I will call this, let's say that's 2C, so twice the distance, right? So, for example, so if this distance was, say, 5, then this over here would be 10, okay? But it's not, but we're just saying, so that's what I mean by C and 2C, so those two are related to each other. Okay, so... and we will call this section here, we will call this A again. Okay. All right, so let's say that we have arc length that we have to find. So for arc length, we would go, so also, before I forget this, so we had two different arc length formulas, just a reminder. So we had the integral from a to b of the square root of 1 plus f prime of x squared, right? And that's what we learned in chapter 6. And then the other one was the parametric one. This one is the one that's not on the test, right? So this would be x prime of t, or dy dt, or dx dt, sorry, plus y prime of t, and then squared, right? So those are the two, so those were the two ones that we had. And again, just a reminder, this is the one that is not on the AP test. So let's say that we have to find the area, or the arc length, excuse me, of f of x. So let's do it of f of x. So then that would be given as, so s equals, so arc length. We would integrate from 0, because it's starting here at 0, right? Because we're doing it on the x, from 0 to 2c. And then the square root of 1 plus, and then f prime of x. And then that is squared, right? And so that would give me that value there. So what if they asked for perimeter? Okay, so what if they asked for the perimeter of or section A? So if they asked for perimeter, then of course it would be the value here that we just found, so that integral. And that would take care of this section here, right? So, but we're wanting perimeter. So then we would also have to, so that we have that section, so for perimeter, we would need this little piece here as well. So we would need to know how long that is. So to figure out that, I would then add the distance between C and 2, so that would be C minus 2. And then one more section, I would have to take into account this piece here. So I would need a little bit more information to kind of figure out like how long that is because it is slope, right? And so I'm going to do just kind of a little pretend here. So so this is some sort of angle there. So I'm going to just go ahead and kind of square this off and make it like that, right? So I would need to know a little bit more information. I didn't give you enough to figure that out, but I know that this section right here is, say, 2C, yeah? And I would need to know, okay, what is this value here? And I could find that by maybe they give us, maybe they tell us that's at 1. Perhaps they give us the slope of g of x, right? So if they gave us actually the equation of g of x, so like let's say that it's, I don't know, negative 1/3 or something like that, x, plus 2. Then I could find out, when x is 0, our y-intercept is 2. That's where I got that 2 from. And then the negative 1/3 I just made up. So then I would know, okay, so what is the corresponding y value at 2c, right? That's what I would have to plug in. So then I would have to let x equal 2c to solve for y, and that would give me what actually that value is, okay? So for example, I would do something like, this would be negative 1/3 times 2c plus 2. Oops. Let me scoot that over so I have a little more room to work. And then I'm going to do it down here. Okay, so let's start that again. So negative 1/3, and then the x value is 2c, yeah, plus 2. And I'm looking to find that corresponding y value. So then that would be at negative 2/3 c plus 2. And so that would be the y, yeah. So that would be kind of ugly, but this right here then would be at negative 2/3 c plus 2, and then I could do Pythagorean theorem from there to find that value, okay? All right, but I'm going to go with my made-up value that this distance here was 1, and I know this is 2c, and so then to find this length right here, that would be 1 squared plus 2c quantity squared is equal to hypotenuse. So that would be 1 plus 4c squared. And so then when I square root both sides, that would give me that other value. And then remember, I cannot simplify that any further, right? Because I can't square root independently. And so then that would be my missing third side. So something like that. Okay, so that would give me perimeter. Okay. And then one more little bit just to kind of help you out here, just as a little reminder, is average value, because that will pop up in one of these questions as well. So our average value, so this would be something you can look up on that summary card, right? So if like you're taking this test and then all of a sudden you're like, oh crap, I forgot average value, just look it up, right? That is something that you should have quick at your fingertips. And so average value is the integral from a to b of f of x dx, and then divided by b minus a, right? Which is just the distance. And then that is equal to what we call average value. And we often use f of c for something like that. Okay? All right, that is it.